All right, welcome back, 7th grade. This is going to be an interesting lesson for sure. We're going to hit Pythagorean theorem again for the second time this year. I know you guys had so much fun with the first Pythagorean theorem that we're going to talk about it again. Not a whole bunch different, just kind of give you something else to think about and apply in your thinking. Today we're going to be on page number 782, lesson 112. And we're going to talk about applications of the Pythagorean theorem, different ways that you can use them. And if you ever get into construction, when you get older, you'll definitely use the Pythagorean theorem. It's a quick way to make sure your corners are at a 90-degree angle. And you want to make sure definitely that they are. If your corner is even off a couple of degrees, it can really throw off your measurements for the rest of the place that you're building. And so you want to make sure that you have a right angle for sure. And construction workers use Pythagorean theorems all the time. But today we're going to talk about the Pythagorean triplet, okay? And the best way I can try to tell you about the Pythagorean triplet is by showing you this. Now, let's quickly review. We know that the Pythagorean theorem is a squared plus b squared equals c squared, okay? We have our triangle here, and remember, Pythagorean theorems work on right triangles. You have to have a right triangle. That's the whole point. We're trying to make sure our angles are at a right angle. And this will be the way we can do that. Here we see, this will be our A, this will be our B. So 3 is our A, 4 is our B, and C, or our hypotenuse, is always the equal to, okay? So the C is always the longest side because you're going to add these two together to get that one, okay? And this long side, remember, is called the hypotenuse. So A squared plus B squared equals C squared, or 3 squared plus 4 squared equals 5 squared. And of course, we know that is true. 3 squared is 9. 4 squared is 16, and then 5 squared is 25, and 9 plus 16 equals 25. We know that's true. We know that this is a right angle. Now, sometimes, though, you may not know all the measurements. Let's look at this example here. Now, watch the relationship between the two. We've kind of talked about this with scale, but these triples sometimes will help you recognize right away if you're dealing with a right triangle, okay? Understand this. I see here that my A is 6, and that my B is X, my C is 10. We don't know what our B is. If I wanted to, I could plug these numbers in. I know my A would be 6 squared, plus B would be X squared. We don't know what that is, and C would be 10 squared. Now, if I wanted to, I could solve at this point for x. All I would have to do is subtract the 6 squared over here. So I would do all the multiplication and doing all the exponent work and whatnot. I would still be able to get x. But I can recognize something here. This is one of those triples, okay? Now watch what I'm talking about when I say this. 3 and 4 and 5 is a triple. Now, we know that if we multiply, we talked about scale earlier in the year, if we multiply by a number, what happens? That scale gets larger, right? It's still going to keep the same shape, but our scale will get larger. So if I multiply this times 2, that would be 6 and 8 and 10. If I multiply this by 3, it would be 9 and 12 and 15. Now, all of these still hold true to the Pythagorean theorem. A squared plus B squared equals C squared. So I can look at this and know, well, this side is the same as the 3 over here. 3 will go into 6 2 times. 5 goes into 10 2 times. So what do you think this would be? What is x? X is going to be equal to 8 because 4 goes into 8 2 times. And so that's what we're talking about when we're talking about triples. If we see some measurements, like if we're measuring this room and I recognize maybe it's 9 feet by 12 feet by 15 feet. That's from the corner to the corner, that is my measurement. Then I know, yes, we're definitely dealing with a right triangle because it is one of these triplets. It's a multiple of the 3, 4, and 5. Okay? So when we're talking about triplets, that's what we're talking about. Pythagorean triplets, that's what we're looking at. Now, let's look at a couple of problems here. Let's look at some of the practice problems today. All of the work is done for you on the examples. Let's look at a practice problem here. And we'll do that today. Let's look at letter A. Okay, letter A. It's going to be a little bit of detail. And again, if at any point you get lost, you feel like, man, I lost him, you can always, review the video. Stop it, go back, catch some of the things that I say. Practice A on page 786 says a 12-foot ladder was leaning against a building. So let's do this building here. Here's our building. It'll be a very bad building. Here's our window. And a 12-foot ladder was leaning against a building. Okay? Here's our yard. Okay? And it says the base of the ladder was 5 feet from the building. So from here to here was 5 feet. And we know the length of the ladder is 12 feet. Okay? The problem says, how high up the side of the building did the ladder reach? Write the answer in feet and inches, round to the nearest inch. All right, so what the question is asking for is the distance from the ground to the top of the ladder where it is resting, okay? Now, if you notice, what do we have? We have a right triangle, okay? Hopefully that's what we have. Hopefully the building is straight up. It's been built well. And I know that the length of the ladder is 12 feet. And the base from the point where the ladder is on the ground to the building is 5 feet. So it's going to be 5 feet squared plus what we don't know is the height. We'll let x be the height, x squared. And that's going to equal 12 square feet. Okay? Because a squared equals a squared plus b squared equals c squared. Now, in this case, we don't have a triple. If you remember those triples that we had, we don't have that in this case. It doesn't work that way. However, what we do have is we have the Pythagorean theorem that we can use to solve this. So what we're going to do is we'll work out everything we can. 25 feet squared would be the a side. 5 feet times 5 feet is 25 square feet. Plus x squared, we don't know that. And then 12 feet squared is 144 square feet. Okay? All right? So let's do this. That would be better. That way you know it's the whole thing. Okay, now, what are we going to do? We've got to get x by itself. So we're going to subtract 25 feet squared from both sides. Okay? When we do that, we get x squared on this side, and then x squared is equal to 119 square feet. Okay? Now, the next thing we have to do is we're going to try to solve for x, so we've got to take the square root of x. So that gives us x over here, and x is going to be equal to the square root of 119 feet squared. Okay? So, in order to solve this, you're going to have to use a calculator today. All right? And I have used my calculator. Let me get my calculator real quick. Get my handy dandy trusty calculator here. And here we go. Okay. Now let me show you how you're going to do this. It's a little different. I'll try to get closer to the screen. There we go. Okay. Now we're in tablet mode. Hopefully you can see this and this will be okay. So I'm going to take and I'm going to put my 119 in. 119. And then I'm going to go up here to the second button. This is, if you have a scientific calculator, you'll need a scientific calculator to be able to do this. On my app, I have a place where I can choose what kind of calculator to work with and choose scientific. Hit second after you put that number in, and you'll see right here the square root button. It automatically will find the square root button. It's got the square, it's got a cube root you can find too, but we want the one with the square root symbol with the 2 out there and the X underneath the square root sign. And we've already put our 119 in, and we're going to hit that button, and it's going to come up with our answer. And our answer is 10.9087. But that does not give us the answer we're looking for, because the problem says to find it in feet and inches. Well, 10.9087, so on and so on. That only gives it to us in feet. That's 10.9 feet. So what we're going to do is we're going to change the feet. We're going to change the inches using a unit multiplier. So we take our 10.9, okay, 10.9, and we're going to round. Okay, we're going to take, this is our feet, okay, but we want it in feet and inches. So we're going to take our decimal, because we know we have 10 feet in there. The decimal is the inches. So we're going to take our 0.9 from here, and we're going to multiply that. This is 10.9 feet. This is 0.9 feet is what that is, okay? And we're going to use a unit multiplier. So the unit multiplier we're going to use, we want to change feet to inches. So 12 inches over 1 foot. Okay? And again, if I lost you, stop it, go back. Okay, we've got our 10 feet here. We've got our 0.9, 9/10 of a foot. We're going to find out how many inches 9/10 of a foot is. Okay? So we take our 0.9 feet, 0.9 inches of a foot, and we're going to multiply it by our unit multiplier because we want to get inches. When we do that, the feet will cancel, and we're going to come over here, we're going to multiply 12 inches times 0.9. So inches, come on down. 9 times 2 is 18. Carry our 1. 9 times 1 is 9, plus 1 is 10. So 108. Don't forget to move your decimal. We got one place, so we're going to go here. So we have 10.8 inches. And so since we have 10.8 inches, we're going to round. That's what the problem asks us to do, to the nearest inch. So since 8 is 5 or more, we round that 0 up to 1. So we're looking at 10 feet, 11 inches. So what's the distance between the base, the ground, to the top of the ladder? This is going to be 10 feet, 11 inches. Okay? Again, Pythagorean theorem it can be confusing and be tricky because sometimes square roots don't work out so evenly. But if you master it, it will be a huge help to you in the long run, okay? So today, remember the triplets, understand that. That's really multiples. It's a quick, easy way. Occasionally you can find a measurement without having to go through all of the a squared plus b squared equals c squared. But even if you have to do the a squared plus b squared equals c squared, it's not too difficult. Just slow down, relax as you go through it, and understand that it works the same way every time. If you have a right triangle, it's going to work every time, okay? All right, make sure you get your work done. If you have questions about anything, please respond back to me or reach out to me, and I'll be glad to help you. All right, have a great day, and I'll see you tomorrow.